Hello, welcome back. We're going to continue our discussion on slope fields and graphing them. Our next example, number 4 right here, is a very big example for us. This right here represents the change in a function. Now, where do we see this one? This is actually our half-life equation from chemistry and from physics. We're going to talk more about this in a later video, but we're going to show how we can get our exponential functions. So you might recall from half-life function, these are your exponential models. And this is, in other words, this is our PERT T equation. And we're actually going to derive these by hand in here in just a few days. And so we want to make sure we know how to solve this. So if we want to make sure what we're looking at and how just important these topics are for us in terms of science and for chemistry and physics. So here, notice like our first example when we graphed it, we're only interested in looking at the x values right up here. In this example, notice we're only interested in the y components. So I only know my y. So like when y is 2, I can say that my slope is just 1/2 of 2, which is 1. So here, where my y values are 2, my slopes are just going to be 1. And I can just go ahead and make them all 1s right there. When y is 1, our slope is 1/2 times 1, or 1/2. And I can do that at y equals 1, half, 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 half. At y equals 0, our slope is just going to be 1/2 of 0, or 0. Now this is interesting, so take a look here. Notice we have a straight line. And in a previous video, we'll review it up here, if we see a straight line, like right here, we have what's called an asymptote. So this down here, our example down here, this is a horizontal asymptote for us. We'll see why this becomes really important for us later on. All right, so let's keep going though. So that's y equals 0, but when y equals -1, our slope here is 1/2 times a -1, or -1/2. So I go -1/2, -1/2, -1/2, -1/2, -1/2, -1/2, -1/2. Very easy. And when y is 2, our slope is 1/2 times 2, which is just -2. That should be -2 there, -1. So at y equals -2, the slopes are just -1s. And what we have here doesn't look like it yet, but this is actually an exponential model. You remember what exponential functions look like? They should look something like this right here. And so let's see if we can see that at the point 0, 2. So here we are at 0, 2. If I head down to the left, if we head to the left, let's see what's happening. The slope is getting smaller and smaller and smaller until we reach that asymptote. But as we head to the right, in other words, as my y values increase, my slope also increases. So we would get something that looks like this. Let me draw this in purple here. So we're heading down here. Now notice you don't have to hit the points. It's not like a connect the dots thing. That becomes asymptotic, but as we head to the right, it's because as my y values increase, so do my values. So we can say that like as y increases, my slope also increases. And I can verify that right here. If y is 4, my slope is 2. If y is 8, my slope is 4. Over here, as y decreases, my slope decreases right here. So as you notice, here my slope is very small, but as my y values are increasing, my slope is increasing. That is the definition of that's one of our definitions of an exponential model. That's really kind of cool. This one right here is big on the AP. Okay, we gotta know this one. All right, so let's take a look here. So these are easy. These are just some AP questions. we want to match the slope field with the function. So here what they're telling us, they're giving us a slope field. And remember, a slope field shows what the function looks like, shows us the shape of the graph. So if I want to find out which one this is, I have a choice. Does that look like a sine curve? Does it look like a cosine curve? Does it look like a parabola, or does it look like a cubic function? And we know what these look like. Well, what does sine look like? It's wavy gravy. Cosine, also wavy gravy. X squared looks like a parabola. Well, that is a parabola, right? And x cubed, it kind of looks like this. So I'm like thinking about, okay, well, they're telling me what the shape looks like. They're showing us the shape of the graph. Whoops, sorry. There we go. They're telling us what the shape looks like. Well, which one of the following of A, B, or C, D does it look like? Obviously, it should be D. It looks like a cubic graph. All right, so you guys try one. Here it is, the slope field for a certain differential equation shown below. Which function does it look like? So these are a little bit harder to do here. Another way we can do this is just pick points. Ready? So if I pick the point at 1, 1, so if I just pick the point 1, 1, and I just plug these in, okay? At 1, 1, if I plug it in here when x is 1, at 1, 1, my slope here is going to be 1/2 plus 1, so 3/2. So it's a positive. That could be a positive 3/2. I don't know, so I keep going. What if I plug in here? If I plug in 1, 1 here, my slope is 1 minus 1, which is 0. Well, that is not a 0 slope. So this is not my choice. Over here, if I pick 1, 1, my slope is going to be 1. So again, this could be a slope of 1. I'm not quite sure because I'm not really drawn here to scale. So that's a possibility. So A and C are my possibilities. Let's go to the natural log. If I plug in 1, 1 here, my slope is just going to be the natural log. Whoops, let me rewrite all that. Looks terrible. Still looks terrible, even worse. There we go. My slope here would be the natural log of 1, which is 0. And we already said it's not 0 because that'd be the same as B. So I'm stuck between the two choices. I'm stuck between choice A and choice C. So I'm going to pick another one. So let's pick 1, 0. I'm just going to pick 1, 0 this time. All right. So 1, 0. My slope here, that's a weird looking 0, would be 1/2. Oops, let me get rid of that. There we go. My slope here would be 1/2 times 1 plus 1. So we would get 1/2 times 1 plus 1. So that would give me a slope of 3/2 again. But look, at 1, 0, my slope is certainly not 3/2. Just to be sure, I'm going to plug it in here. If I plug in my point 1, 0 here, we're going to get just 0. That's a horizontal line. That's our horizontal line right there. So our answer here at 1, 0, that does look like a horizontal line there. So our answer choice is, of course, C. So there are two ways we can do it. One, we can just recognize the shape if you can recognize it, or you can just plug in a bunch of points. I hope you guys enjoyed the video. I will see you all later. Bye-bye.